So what we're going to do is we're just going to quickly review balancing chemical equations like you've learned last year in grade 10. Now, just a quick reminder of chemical change. Remember, it's a change where any new substance is formed, whereas compared to a physical change, it's a change in state or form. Okay, and we have our evidence of chemical change, right? Where we can have a color change, we can have formation of a gas, heat or light can be given off, or we can have a precipitate form. Now, when we want to represent our chemical change, we can do it with a word equation. And with the word equation, we use the names of the chemicals involved. And we state their chemical names. So for example, let's say zinc metal reacts with silver nitrate solution to produce solid silver and zinc nitrate. Okay, or we can use, what we use more often than not is a chemical equation where we use our chemical formulas of our entities and we use coefficients to ensure that the law of conservation of matter is obeyed, and we include the states of all of the entities involved. By states we mean solid, liquid, gas, or aqueous. And so if we were to take our previous example, we'd have our zinc solid with our silver nitrate to form zinc nitrate and silver. And we can notice the coefficients to ensure we have the right numbers of each. Okay. Just a reminder of the law of conservation of mass or matter. During a chemical change, matter cannot be created or destroyed. During a chemical change, we're just changing the arrangement of the atoms. Remember, when we're balancing, some of the quick steps, we write down our equation. We can write down how many of each atom type we have. When we are doing this, we will start off with any elements except for hydrogen or oxygen, and then we're going to come back and do hydrogen and oxygen at the end. So let's take a look at a couple of examples. Okay, so let's take a look at our first example. And as you learned last year, you'll make yourself a little chart with your left side and your right side. We're going to list the elements present. And as we stated, we list oxygen last, hydrogen second last. Then I'm going to go here and I have one zinc. And look here, one zinc, one sulfur, two oxygens. I have three oxygens. Now that I've counted, I'll go through and I'll say, okay, is zinc balanced? Yep. Sulfur balanced? Yep, because I have the same number on both sides. Oxygen balanced? No. And this is one of those cases where if I have even on one side and odd on the other, the only way that we can balance it is if we go back and double the coefficient in one of them. So I'm going to put a 2 there. And so that will change the number of each of these. Because now since I have 2 of these, I have 2 zincs and I have 2 sulfurs. So now I'm going to come over here and I have to balance my zinc. So I'm going to put a 2 there. And I'll balance my number of sulfur. I have to put a 2 there. And now when I look, I have 2 oxygens plus 4 oxygens, which tells me 6. So now what I'm going to have to do is I'll put a 3 there so that that balances. And so therefore we have and we just have that as our balanced equation. Let's take a look at another example. So here we have our example. Again, I'm going to make my chart. I'm going to list my elements. 2 vanadium, 2 hydrogen, 5 oxygen, just the subscripts. 2 vanadium, 2 hydrogen, and 4 oxygen. Or sorry, yep, 4 oxygen. So now when we look, vanadium is balanced, hydrogen is balanced. Oh, oxygen is not balanced. Again, we have our even and odd. So what I'm going to do is I'm going to go back and I'm going to multiply the coefficients of the things that are balanced by 2. So I'm going to put a 2 here, and then I'm going to put a 2 there as well. So now when I go, I have 4 hydrogens, and I have 4 of those. That means that I have to put a 2 here. I'll turn that to 4. And I have to put a 2 here. I'll turn that to 4. And now when I look, I have 2 times 3 is 6, plus 2 is 8, and I have 10. So as we can see, we still haven't been able to balance. But what we can do is, we notice that if we just put a 2 here, if I were to decrease that by 1 to 1, then I have actually my original there. I'm going to put that down to 1. That'll be my 2 there. Now if we count, we have 4 hydrogens, we have 4 hydrogens, we have 3, plus 2 is 5, we have 5 oxygen. So sometimes when we do it, we make a first attempt to balance, and then we don't get there. So as a result, this now would be 2H2 gas plus B2O5 solid goes to form B2 solid plus 2. Okay, and so sometimes when you try something, you'll see that it doesn't work, and so we have to go back and try again. So now let's take a look here, and again we're going to make our chart. So Mn, then Cl, then H, and then O. So I have 1 Mn on that side, I have 1 Mn on that side, I have 1 Cl over here I have 2 4Cls, I have 1 hydrogen, 2 hydrogens, I have 2 oxygen, and I have 1 oxygen. Okay, so Mn is balanced, Cl is not, so I'll put a 4 here, and that balances that, and that moves that up to 4. Then now Mn is balanced, Cl is balanced, hydrogen, I put a 2 there, that'll bump that up to 4, and that changes my number of oxygen, and so therefore we would be balanced like that. Okay, one final example. Okay. Fe, L, N, O. I have 1, I have 2, I have 3, I have 2, I have 1, I have 1, I have 1, and I have 3. Okay, so first thing I need to do is I'll balance Fe. To do that, I need to put a 2 here. I'll change that to 2. But also change my number of chlorine to 6. So now Fe is balanced. Now I go here. I need to put a 3 there. I'll turn that to 6. That changes my number of magnesium on this side. So it's 3. So now 2, 6, 3. I have to put a 3 there. And that changes my number of oxygen, and then I can see everything is balanced.